Today's lesson is on writing linear functions. You can write a linear function given the following information. 1. Given the slope and y-intercept of the graph. 2. Given the slope and 1 point on the graph. Or just given 2 points on the graph. We're going to go through each example. Write a linear function given that the graph of the function has a slope of 4 and a y-intercept of 1. What we're going to use is the fact that y equals mx plus b is a slope-intercept form of a linear line. M represents my slope, and b is my y-intercept. So we know the slope is 4 and we know the y-intercept is 1. So what you're going to do is say y equals, and the slope is 4, so you put 4x. Since the y-intercept is 1, we put plus 1. And if you want it in function form, you can express y as f of x. So you write it this way, where x represents all the input numbers. And your function rule is 4x plus 1. That's it. Write the linear function given that the graph of the function has a slope of 0 and a y-intercept of 6. So this time we know the slope is 0 and the y-intercept is 6. So we're still going to use y equals mx plus b. So we have y equals, well, the slope is 0, so we have 0 times x. Y-intercept is 6. But 0 times any number is 0. So you have y equals 0 plus 6, which simplifies to y equals 6. If you put that in function notation, you're going to put f of x equals 6. This is known as a constant function. Write the linear function given that the graph of the function has a slope of 1/2 and passes through the point 2, 3. So now we know the slope is 1/2. This time, we don't know what the y-intercept is. You can't assume that the y-coordinate is the y-intercept. That's just a point on the line. So we know it passes through 2, 3. But this tells us that the x value is 2 and the y value is 3. So I can substitute that into this formula, y equals mx plus b, and solve for the y-intercept b. So we're going to say y is 3. The slope is 1/2. X is 2. And we're going to solve for b. If you multiply 1/2 times 2, that's the same as dividing 2 into 2, which is 1. So you subtract 1 to both sides. This tells us that the y-intercept is 2. And then you just go back and do what you did in the previous examples. We know that the slope is 1/2 and that the y-intercept is 2. So we're going to simply say y equals 1/2 x plus 2. If you put it in function form, you put f of x equals 1/2 x plus 2. Write the linear function given that the graph of the function has a slope of -1/4 and passes through the point 8, 2. Well, again, we know that the slope is 1/4. We know it passes through this point. So the x-coordinate is 8 and the y-coordinate is 2. We substitute that to y equals mx plus b. So if my y coordinate is 2, I put 2 here. My slope is negative 1/4, negative 1/4. My x coordinate is 8, and I'm solving for the y-intercept b. So look, 4 divides into 8 2 times. But don't forget this is negative 1/4. That makes a difference with the direction of the point. So this is going to be a negative 2. And the opposite of negative 2 is positive 2. So we know that b, the y-intercept, has to be 4. And then you just put it back into the equation. Y equals negative 1/4 x plus 4. Or in function form, f of x equals negative 1/4 x plus 4. All right, let's look at an example where you're just given 2 points. Write the linear function given that the graph of the function passes through a negative 3, 8, and 0, 5. Well, the first thing you have to do is get the slope. We know the slope formula is the difference in y divided by the difference in x, or the x coordinates. You have to be consistent in the way you subtract these. That's why I put the subscripts in the formula. Let's say I start with negative 3, 8, and 0, 5. So I'm going to say 8 minus 5. But then I have to say negative 3 minus 0. That is 3 divided by negative 3, which is negative 1. So my slope is going to be negative 1. So what you do, you go back to the formula, y equals mx plus b, and you pick one of the 2 points. It's best to pick the easier point with the smallest numbers. I'm going to pick 0, 5. That means x is 0, y is 5. So I'm going to put 5 equals, my slope is negative 1 times 0 plus b. Negative 1 times 0 is 0. So this tells us that the y-intercept has to be 5. But a shortcut is, if you notice the pattern, 0, 5, if x is 0 and then you see the y coordinate here, that means that's the y-intercept, because that's along the y-axis. So you can use this to plug in for the final equation. So we know the slope is negative 1. So negative 1 times x plus 5. Or I can just say f of x equals negative x plus 5. And that's my equation. I write the linear function given that the graph of the function passes through the points 0, negative 3, and 4, 3. Well, again, we have to get the slope. So let's say I say 4, 3, and I'm subtracting that from 0, negative 3. All right, so the y coordinates, we have 3 minus a negative 3. Remember, this subtraction sign is part of the formula, so it's fixed. So 3 minus negative 3. Then I have to go this direction, 4 minus 0. So this winds up being the same as 3 plus 3. And 4 minus 0 is 4. So this is 6 over 4. Always reduce. So we know that 2 divides into 6 and 4. So this reduces to 3 halves. So you have a slope of positive 3 halves. And if you notice the pattern here, I have a 0, negative 3. So I can just simply say, it tells me my y-intercept is negative 3. So I can say y equals 3 halves x minus 3. In a function form, I'm going to say f of x equals 3/2 x minus 3. What if you're just given a line? Then what do you do? First thing I would do is find that y-intercept. Where does it cross the y-axis? Here's my y-axis, here's my x-axis. So this point here, start at 0. X is 0, and you count up 1, 2, 3, 4. That tells me that's my y-intercept. And you can pick any point of the line, but I think it's easier to play with the intercepts if they're whole numbers. So let's try the x-intercept. When y is 0, that's down here. You're not going to the you're not going up or down. How far to the right do you go? So you go 1, 2, 3, 4, 5, 6. So this is 6, 0. And if you want to know the slope, you can use the slope formula, or you can count over the rise of a run. To be safe, it's just good to use a formula. So I'm going to subtract 4 minus 0. And then 0 minus 6. That means the slope is going to be 4 over negative 6. And again, 2 divides into 4 and 6. So the slope is going to be negative 2/3. So if you have that information, you're going to say that this line is going to be y equals negative 2/3 x. And I'm going to say plus 4. In a function form, I can just simply say f of x equals negative 2/3 x plus 4. And this function represents that line. Okay, what happens if, again, if you're just given the line? Now notice in the last graph, that line was going downhill. And you notice that slope was negative. Notice that this one from left to right is going uphill. Let's see what happens with the slope. Let's see what that means. It passes through the origin, I notice. That's my y-intercept. And my x-intercept, really. So this is 0, 0. And you can pick any point on the line. So if I go to the right 1 and go up 1, I get the point 1, 1. So let's say I say 1 minus 0, then 1 minus 0. That just gives me a slope of 1. So you can say y equals, and my slope is 1, so I'm going to say 1 times x. And notice the y-intercept, it doesn't pass through any numbers that are positive or negative. It goes through the origin. So that means that this is 0, because y is 0. So you get y equals x is the equation of this line. In a function form, you're going to put f of x equals x. This concludes my lesson for today.